Hi guys, welcome back to another video of me teaching, and today I have this question on the board for you guys. So why don't we just enter the question? Okay, so this question is C is equal to cosine alpha plus theta plus cosine alpha plus 2 theta plus all the way until cosine alpha plus n theta. Now, if you think of this as a trigonometry problem and you use trigonometry identities to solve it, it will be very complicated. But instead, we are going to use the power of complex numbers. So, when you see cosine of something, you can just think that it is just, example, cosine alpha plus k theta is just the real part of EI times this. Right? And this is where the complex number comes in. So, if we actually add all of these until cosine alpha plus n theta, which is the real part of EI alpha plus n theta, then it will become a sigma, right? So it will become the sigma when k goes from 1 to n of e to the I alpha plus k theta. Now this is simply just the sum of a GP. So we changed from a very complicated trigonometry problem into a very simple sum of a GP. So, firstly, I'm going to expand this so it becomes e to the I alpha plus I k theta. And then I will change it into e to the I alpha times e to the I k theta. Because in the end, it will just be e to the this plus that. So, does e to the I alpha has k? No, it does not. So we can simply take it out. So it's equal to sigma k equals 1 to n. Oh, sorry. You can take it out. E to the I alpha times sigma k goes from 1 to n of e to the I k theta. Now this is just a very simple sum of GP. Now, do you remember the formula? Well, I'm going to tell you. The formula is, so of course you have to keep this. So the bottom is 1 minus the common ratio, which is e to the I out, which is e to the I theta. And then the first term, and then the top is the first term, which is when k equals 1, which is e to the I theta, multiplied by 1 minus the common ratio, which is e to the I theta, but raised to the power of n. So it will just become e to the I n theta. So I will put these two together, so it becomes e to the I alpha plus theta multiplied by this over that. So 1 minus e to the I n theta over 1 minus e to the I theta. Now we're going to find out the value of 1 minus e to the I theta. Okay, so if you have watched one of my previous videos, and I highly recommend you watching that, then in that video, we only covered the modulus of 1 minus e to the I theta. Okay? And we found the modulus using a very fundamental and elementary method. But today, I'm going to show you a cool method. But before we do that, if you just want a slight recap of what we did in that video, I'll draw you. So, if you have the Argand diagram and you have a unit circle, then we see that 1 is, of course, since this is the unit circle, this. And then e to the I theta is this. And this is theta. So 1 minus e to the I theta is just, if you think of it as vectors, then e to the I theta, or 1 minus e to the I theta, is just a vector heading from this point downwards there. And then in that video, we explained how to find the length of this small section. But in this video, we're going to use a very small technique. So what am I going to do? Well, I'm going to take out e to the I theta over 2. Okay, so equals ei theta over 2 times, the inside will be, this is e to the negative I theta over 2 minus this, which is e to the I theta over 2. Now, this looks quite uncomfortable, right? Because the negative is at the front. So, if we put a negative here, then we can swap this. So it becomes negative ei theta over 2 times ei theta over 2 minus e negative I theta over 2. Now, we have explained this concept many times already, is that a complex number minus its conjugate, and the reason why its reciprocal is its conjugate is because this complex number has a modulus of 1. And we have many videos explaining about modulus 1. So, a complex number minus its conjugate is very easy to deal with. It's just the cosine parts will cancel out and there will be 2 duplicates of the sine part. So this will become negative ei theta over 2 times 2i sine theta over 2. Now, we can make this a bit more simple by we're going to put the terms without the I at the front and the terms with the I at the back. So it will become negative 2 sine theta over 2 times I times e to the I theta over 2. Now, if you have watched my previous video, then you actually know that the modulus of this is just this. So we can also get that from here, as the modulus of both of these are 1. So this is the only thing that matters. Now, we're not going to do that. Now that we know what 1 minus e to the I theta is, we can easily figure out what e to the 1 I n theta is. We can just replace all the thetas here with n theta. So I'm going to rub out the board and then we'll see what we do. Okay, so now we have all the important information, and I'm just going to give you a little reminder that the thing that we're actually trying to compute is not the sum, but the real part of the sum. So we can't see any complex numbers in our actual final answer. Okay, anyways, now we can figure out 1 minus e to the I n theta because we already know this. So we replace all the thetas with n theta. So it becomes negative 2 sine n theta over 2 times I times e to the I n theta over 2. So now this becomes, so we keep that intact. It becomes e I alpha plus theta, and then multiply by this at the top and this at the bottom. So it becomes negative 2 sine n theta over 2 times I times e to the I n theta over 2. And then the bottom is this one. So negative 2 sine theta over 2 times I times e to the I theta over 2. Okay, and now we can see that many things cancel. This, that, this, that. Not really many things, but still it's good. So with all of these cancellations, it will just become, I will actually put this first. So sine n theta over 2 over sine theta over 2. And actually, fun fact, this is something known as the Dirichlet kernel. And so we actually could have just used this formula from the start, but I didn't want to because this is cooler. Anyways, now we have that. So e to the I alpha plus theta. And then multiply by e to the I n theta over 2 over e to the I theta over 2. So I'm going to keep this. And then this bit will be e to the I alpha plus theta plus n theta over 2 minus theta over 2. And if you do this on your own, the answer will actually just be e to the I alpha plus n plus 1 over 2 theta. Okay, so now we have this, and this is actually the answer to the sum, but not, beware, the answer to the question. Because the question wants us to find actually the real part of this sum. So we want to find the real part of this. I'm going to write it down here. So the real part of the stat sigma is just, it's not this because we have an I. So this does not have any I's, right? So we keep that. And then we times. Now, isn't this just e to the I of some angle? So the real part is just cosine of that angle. So times cosine of alpha plus n plus 1 over 2 theta. So this is the final answer to this very interesting trigonometry but complex number question. So, thank you guys so much for watching, and if you enjoy my video and you want more videos like this, please consider liking and subscribing. If you want to master something, teach it.